everyone. Thank you so much for joining us on our new webinar about revolutionizing in the manufacturing with artificial intelligence. I'm sorry, for artificial vision, boosting efficiency and accuracy. Today, our CIO, Mario Lopez Baratas, is with Raymond Lo, a software evangelist at Intel Corporation, and they will be explaining how computer vision technologies can improve the efficiency and accuracy in the manufacturing production lines. Thank you very much, Raymond, for joining us. You can start.
Great, thank you. Mario.
Yes, hi Raymond. It's a pleasure to stay today with you.
In a while.
How are you doing?
Good. It's raining outside. It's rare in California.
Raining?
It's raining.
That's so weird.
That's weird.
So you have something very cool for us to show today.
Yes, that's exactly why I'm here. So we met many years ago, 1 and 2, I think. And we met because of manufacturing. And today I got to talk about a little bit of my background because I did manufacturing. I built headsets, the augmented reality headset. I built it not once, but twice. But also I have my evangelist in my team also did manufacturing. So I like to bring some of that story and then see how Intel and everyone, what they're working on. And that's why I'm here.
Fantastic. So let's go ahead.
All right, I will start sharing my slide.
Perfect.
Just bear with me for 1 second. Okay. 1 second, full screening. All right, I think everyone can see the slide.
Yeah, you can see it.
So, well, again, let me reintroduce myself quickly, what I've done before Intel. I was actually doing startups in Silicon Valley. So my company at that time is called, guess what? Meta. So it's always a fun story. In 2015, at that time, the co-founder and I came to Silicon Valley and started a company to do this headset. So back then, I was doing my PhD on this work. So I built a headset, but in the lab settings. But that time, we launched the product, and then we actually get customers. Now we have a big problem because not one headset. I need to build 100, no, 1,000 of this. And of course, to get that happen, we get into Y Combinator, YC, and we fundraise. And we actually pre-saled it. But now here's a real problem. We have to ship it within 18 months. And that's how it started. So we have this amazing promotional video with millions of people saw it. And then behind the scene, we can see everything is a prototype. It was actually a shell there. So how do we turn that shell into a real product? Oh my God. And I was a CTO. So it was one of the most stressful things that ever happened to me because this is the actual board of my priority months before shipping. Nothing was working, right? I have to go through certifications. I have to make sure that revision is in the right board. I have to make sure the control board is in place so that I actually get the manufacturer in China at one point. So we have to get those injection molded part to be shifted. Then we also have to make sure we have the serial number so we can know, okay, which one goes wrong, we can do recall. But more importantly, we have to put this all together. By the way, if you have any questions, feel free to ask me because this should be interactive. Yep. And here we go. We have all this part together in a manufacturing facility. One thing you notice where there's a lot of almost like handmade tools everywhere. And then we put diagrams of how things should look like. And we have to train staffs. We have like shift after shift to make this happen. And every day we just find new problems. From manufacturing defects all the way to just a circuit board was not tested. So at that time, our team every day was in the ground, just figuring out what's wrong. Because if you look at this lady here, when she's soldering, sometimes people may miss a tiny piece of the component, we don't know. So we actually have to go through like a unified testing at the end. But more importantly, at that time, we realized, wow, manufacturing was hard. Everything was really manual, and then it was really hard to see how this can be automated, especially in low volume at that time. Now, here's another clean room. We have optics, right? Because I was building eyeglasses. And we even have these kind of room for testing radio frequency, making sure that it's not like emitting something, may mess up your Wi-Fi, basically. And after all this work, what happened were we have this first prototype that close to call it PPT. So as a version that production ready. But at the moment we thought it's ready, the part is not fitting. So there's some small problem that I end up flying to China, and they say, okay, the part is not exactly the size I wanted. I was like, oh dear
Oh my God.
Here we go again. I thought I did my inspection correctly. How come it strings a little bit? It's not fitting. So I have to go back to the original diagram, shaving up millimeters here and there to call the make fit. So there's a lot of lesson here. I will talk about how we can do this better. But more importantly is I was there. Like even I was the executive of the company at that time. I have no other choice. I would be in the production room next to the folks and say, guys, this is wrong. And we have a circle of hands. It was a very painful process, but I think at that time was needed because we are not experienced. And eventually when all come together, this product was very interesting. It was one of the very first augmented reality headset in the market that come with a software development kit. And we have thousands of users sign up to be ready to try it. And only months before we're gonna ship it, we find out one last problem. We have this depth sensor 3D glasses, right? They're not calibrated, we realize. So we actually have to build a pair of eye. This is my eye there. Because initially I have to use my eye, and I realized I cannot do this 1,000 times for the next 2 months. Then we have to build this artificial vision, my human eye, to simulate exactly what we're seeing. With this, now we put this chart together using the tiny QR code for calibration, and also using that to calibrate our depth sensor. Eventually, we get a configuration file just for this headset. And at one point, I felt like I'm building a little robot just to do my work. You can see here, the robot was just looking through the lens to see if the eyesight is still good. And after all this work, right? Oh, wow, this product is ready. I'm talking about 18 months of work. I summarized it in 5 minutes for you. But that 18 months of work turned into one product, and we're able to run like hackathon and everything with it. And of course, this is only part one of the story of what I was doing there. But the big lesson where I wasn't alone. There's a lot of folks helping me, and I knew at that time someone else in the other side of the world is facing the same problem. Because if you're ever innovator, you are building anything in life, you hit some sort of manufacturing. If you're not doing software, you're gonna build something, right? So I talked to my colleague just yesterday as well. Is Paula. Paula is one of our evangelists. So I asked her, what did you do for manufacturing? Then she showed me this. I was like, oh, she built a camera to look at props. I was like, really? What does it do? So it was called a stress cam. What it can do is it can monitor the crops and making sure that they have the right sun, everything, just to making sure these crops are at the right, kind of like humidity, everything, monitoring, right? And she built this prototype for the university at that time. And she didn't just build one. Again, she built hundreds of this on the field to do like a field trial. And look at what she was doing. No difference than what we have done before, right? She got a PhD as well. She still have to do things drilling hole on a box, right? Similar to what I did for Meta. It was literally a plastic box with a lot of holes. But actually, you can see manufacturing, even a camera system like that, took her many, many months of effort. And I'm flashing this photo just for the fun. And then you can see she's very hands-on, and just like me, we have to get onto the problem, try to figure out how to build something. Okay, so that was a very interesting part. What have we learned so far? So this flash story is just like everyone doing manufacturing will face one part of this at one point, like defects, scaling with workers, all this like things that never expected has to come up. And you have very short amount of time to turn around. You cannot plan years ahead if you're doing a prototype example, especially you're doing the first run. There's a lot of issue came up. What we learned is you have to really tightly integrate a solution with the manufacturing floor on the same day and the same time. So I think that's what's happening these days. The world is changing so fast, and AI is one of the very important tools that allowing manufacturing to be faster. Because remember, I was shipping in 18 months, I was late. Imagine I ship it in 36 months. I won't be late, I'll be out of the pictures, right? So that extra months matters. Every second counts. So manufacturing to me is almost like a little my darling in my heart, because it was one of those that you really love, and kind of awkward relationship. And in 2022, anyone know this winner? Who's the winner here? Mario? Who's the winner here?
I think so. That's us.
Yes. So when we actually looking into AI use cases in 2020, so one thing that actually emerged, especially we find interesting, is machine visions with manufacturing. And for example, in your winning case, we're literally assembling parts. And then to me at that time, it's like, oh my God, I wish I had it a couple years ago. Then it would save me so much time, right?
Money.
So
money.
yeah. And same thing, let's say in 2022. So we run more hackathon, right? One thing we observe again, we run it in Taiwan this time. So Taiwan, of course, there's a lot of manufacturing happening there. We see people actually looking into how to use computer vision or artificial vision for enhancing robots. So this is a very interesting prototype they're building, or actually a product they're building. They have these old robotic arms everywhere these days in manufacturing floor. What they have done is they augmented these robots with a camera and the brain. The brain is the AI, right? So to do many things that it cannot be done otherwise. So funny fact is, robotic arm doesn't change too much in the last many years, right?
Yeah.
Arm is arm. Like if you take one that's 10 years old, you can still pick up an egg if you do it right.
Totally the same, more or less. Yes, it is.
Yeah, but today, let's say you look at the computer vision system, is a completely new, almost like a species, right? It's like a new evolution. And so by combining these, they can revive some of these robotic arms to turn them into a very useful and smart tool. And the other one we saw were, when I think of manufacturing, I always think of plastic and metal. I didn't know we could do diamonds. I was like, oh dear, So diamonds is an big industry because I think my wife has one, like diamond rings, there's like a huge industry behind it. But more importantly is the inspection part were very expensive, the certifications. So we see effort, this is the winner's work. And they were able to inspect diamonds and be able to certify them very quickly. And that was very impressive because when I was looking at the solution they're building at that time, this makes sense because I think human may miss some of these sub details, but with machines, they can look for these very, very critically and be able to do a batch of them in no time. So again, what we learned so far is these come together with a lot of people. So the manufacturing or AI or the computer vision field been growing significantly. That's what we observe at Intel. And then from this desktop, you can see a lot of team member here. Almost half of them actually have some experience in that way. So couple interesting thing is from hackathon, then let's talk about what we've been seeing as well from our partners as well. Is I've picked a couple of this handpick because I find them quite interesting and intriguing. So this one is interesting because they actually doing the inspection for chips. So Intel is a chip company, right? We build chips. And then I see our chips is actually used to build ways to solve the chip problem. It's like, wow, so meta, it's like going the loop. So I find this quite intriguing is how these tools can be now expanded beyond like what we imagined in the beginning. And then some of this you're seeing today is, for example, for their edge use case. I would love to see maybe a robot one day doing the inventory because it's one of the big reasons why we have a lot of food waste and shelf time because people may not manage them very well in the supermarket. And we find that very, very useful. And we also I saw a couple examples like, oh, inspections. I just realized how important inspection were after I found my company. It was kind of like, that was a old learning. But if people are doing any product today, doing inspection early is very good. Trust me, because it was very painful to do it yourself later. So having this in place, having this ISV we see is it creates a lot of momentum. So this field has a lot of interesting player now that come together. I think they work collaboratively because there's never one single solution in manufacturing, right? You see, there's a different stages, and each of these stage we need some help. And the last one I think I find it interesting is the processes, because remember my table with all the diagrams? Oh dear God, that was rough. So let's stop here for a second. Any questions? Because I gotta talk about what's behind the scene to make it work.
This is the most important thing.
Yeah, one of the most important thing. So let's talk about the OpenFino quickly. So behind the scene, you may see OpenFino comes up a lot of time. And what is it exactly? To you, let's say you're machine learning engineer, you have software background. This is the key optimization tool that allow you to take a lot of those models. For example, we talk about defect detection, and you want to run them on, let's say, a laptop, on your small machine to do this inspection, or maybe on a server. So this OpenFino allow you to tap onto all this hardware portfolio of hardware with a single tool, and more importantly, it's optimized. So optimized means it's actually running significantly faster. And I do have a demo actually coming up next. You can see I can run, for example, on my GPU very efficiently, and things like that is only can be done if we have. I gotta actually start my demo on the right side. I just realized I have a demo. I gotta run it. But the key is these optimization tools are very much designed for example edge use case and even Xeon, because we have the compression tool to reduce a lot of compute on the edge. So for example, we have one tool called NNCF. It's called post-training quantization steps. So we can take on, for example, one of those computer vision model and be able to, what we do is quantize it, means like turning it from floating point to integers and be able to execute it on a CPU or GPU. But what it does is actually it's a lot faster, because if you look at the outcome for the accuracy, I don't think you will see much of a difference there. But if you look at the performance will be easily 2 to 3 times faster with the same, approximately same output. So for example, when you're tracking parts in a machine, for example, very likely you will not miss it. You most likely have a dust on the sensor has more problem than that. And if you want to track ducts, I don't know if that's the one use case, then it still works too. So, and then they say it's bird, so we have to fine tune it to say it's specific type of ducts. So what we have learned so far were manufacturing is hard, and today we have a lot of ISV, a lot of partner working on this. So from Intel perspective, we love to provide tools. So we have a lot of these examples today. So one example, if you want to do object detection, we have notebooks for you to try. Notebook is one of the demo example we have. So, and if you want to estimate pose, I have an example for that too. So what it does is it will show, what happened is it will show people, let's say the gesture, like the pose, and then that will help on the safety, worker safety, for example. And we have action classification. So the use case here is very simple. So if you want to know if someone did something like a laundry, you can actually know if your kid did laundry here. That's a very important use case, maybe. So joke aside, but this can be used for a lot of applications in the factory as well. And on this side, we have data transfer just for fun, but also we have text spotting. We find this extremely critical for a lot of use cases because you may want to scan some of the text from some of the objects to ensure you do inspections. And guess what? We also have the fun part. We have generative AI in OpenFino. You don't believe me? Try it. So we actually also on the trend right now. And if you're interested in doing very fun stuff, you never know. Maybe this one use case, you can use it for your manufacturing. And YOLO, YOLO, YOLO. We have almost all the YOLO you can think about. And what's YOLO? It's one of those object detection segmentation. It's an architecture, I would say, for solving these problems efficiently. YOLO means you only look once. It's a very interesting architecture. And I gotta show a demo of that because my team always build fun stuff. So we always think about demo, and then I gotta show you one demo, and then I gotta pass it to a person right after. Are you ready for demo, guys?
We are ready.
Yep. And now I have a problem. I have to figure out how to get on this machine and run something. All right. How about you go first so I can set up the demo? I forgot to set up. All right.
Yeah. Do you want me?
All right,
to
and
continue?
then we'll talk about the demo setup. I don't want to waste everyone's time. So I gotta go on the right side. When it's ready, I gotta ping you. Sounds good?
Okay, no, don't worry. Don't worry, Raymond.
I could switch machines. I forgot here.
Right. Don't worry. But we are expecting your demo, of course. But
yes, of course.
Don't worry.
Don't worry. I have to set up on the right side. Give me 1 second.
Yeah. Yeah, I love it, your presentation. I think that this is really interesting. How you started in the manufacturing and all your stories. For me, it's really, really, really interesting. So let me share my screen. I think that is now working. Okay, so thank you so much, Raymond, for your presentation. As I said, it's really, really interesting. And now from our side, I will be talking about different use cases and how we are applying computer vision in manufacturing and how we are using those technologies, how we are applying all of them and the different use cases that we are getting from different clients. So now let's start with the asset management. In this case, we are using computer vision, for example, to count the assets that we have, for example, in our warehouse, in construction, or in whatever place we have. We can just use a camera of our device, or we can take a picture, or we can record a video. And in real time, with the technologies, Raymond, that you were saying, we can analyze what is happening, and we can, in real time and on edge, we can analyze, for example, in this scenario, count how many parts do we have in our warehouse. So imagine how many time, how many money we can save for your company just using the technologies. In my opinion, the change that we are seeing is how easy it is now to integrate these technologies. Because I remember, like you were talking about the different technologies, but I remember that I feel that 10 years ago, more or less, we started to see some technologies about computer vision. But the main difference is how easy it is right now to start using these technologies, how easy it is to do it on edge, because now the performance that we have in our machines, the hardware that we can get, is very, very, very powerful. So we can do something like this very, very easy. I remember 10 years ago that it was so difficult to analyze what was happening. It took a lot of time, and now it's very, very easy to do this kind of thing. So we are seeing several use cases like this. Now let's talk about safety systems. And in this use case, we are analyzing also in real time using a camera. We are analyzing, for example, in the right video, that I'm wearing a vest, I'm wearing a helmet, or in the other video, we are seeing even that if a person is wearing a face mask. So as I was saying, just taking a few pictures or just recording a video, we can analyze those things, and we can send an alert or send this information to our database or whatever we want. Now let's talk about connected spaces. Something also that we can do is analyze what is happening, for example, in a store or in a warehouse. Using, for example, our own security cameras. This is something that we are doing with several clients, just taking the video directly from the cameras and analyzing on edge with several algorithms. We are able to detect, for example, how the assets are moving around the different spaces. We are able to analyze the products, for example, reading with OCR the text that we have in the products. We can analyze everything that we want. For example, we have with a client this analysis that we are getting from a store. We are analyzing everything that is happening in a store. We are analyzing the time that the person is inside the store. We are analyzing if this person is buying something or not. We are analyzing, for example, if they are coming with a brand for our competitors. We are analyzing the gender. We are analyzing the sentiment. We are analyzing everything that is happening inside our store. But we can do the same in other different spaces. For example, as I was saying, in a warehouse. So imagine the possibilities of these technologies and imagine what we can do. Also, we are creating or we are analyzing the paths that the people are following, that the people is following around the store. We are analyzing the times, and also we can create some heat maps about how the people is moving around the store. So as I said, imagine the possibilities because we can work in several use cases. We can detect everything that is happening in the stores, and we can store and analyze everything. And now let's talk about our solution. And here we have the same story, Raymond, because we started with the solution after the challenge when we met like 3 or 4 years ago. We started
long ago.
Yes, a long time ago, because we started to create several POCs. We started with several clients to investigate in computer vision. We started to investigate some technologies, and finally, we decided to create this product because we started to see that this product and this technology is so interesting in manufacturing, is so interesting for several clients. So we decided to create that, and we started to work with you. And this is why we are using your technology. We are using your hardware because for us and for our solution is a very, very big advantage. And the several or the different use cases where we can apply this technology and this solution is really, really incredible. So the solution is focused on manufacturing. We can apply it on different industries, but right now we are focused on manufacturing. And it's a solution that we are applying for automated inspection. So imagine, Raymond, also for your glasses, for your augmented reality glasses, how you were able to apply this technology and this solution.
I wish you were there for me. I just I lost many hours of sleep. I mean, years of sleep.
for sure.
It's not
so
easy. Nothing was easy there.
No. So after creating these POCs and after participating in different challenges, we decided to create this product that we are right now selling to many different clients around the world. And we can use this solution for several use cases. We are using this solution to do predictive maintenance. We are using for material detection, for inspection, classification. You can imagine probably 100 or 1,000 of different use cases where we can apply it, because the power of this technology is really amazing, and it's very easy to apply in other use cases. Right now, we are focused in inspection and in quality assurance because most of the clients that we had in the past and we are having right now are related to quality. So we are focusing on that, but as I said, we can apply in many different use cases, and we are starting to work in other because we are seeing that is so interesting. So what we are doing we are helping our clients, of course, in the hardware optimization. We are providing the cameras, we are providing the hardware. Of course, we are using Raymond, as I said, Intel hardware, because as you are seeing in the next slide, we are using OpenVINO. This is the
I see a
heart of
demo right here. It's running here.
It's
Click a button.
it's our heart of our solution, and we are using OpenVINO, so we are recommending to use Intel hardware. We are working, and this is probably the most important thing of our solution. We are working to train the different algorithms, and we are preparing everything to use the models in our solution. We are training everything that you want to analyze. We are tagging and detecting and analyzing, and finally training the AI models. And finally, we are doing the implementation and integration with your system. Imagine that you have to store the information in your database, or you have to send information to your operator, or whatever you need. We are doing the integration, and we are doing everything to ensure that we have fully integrate our solution in your system. This is what we have in our solution. We have first the industrial vision camera. This is the hardware that we are using to take the pictures and also the video to analyze in real time. Of course, as I was saying, we are using Intel hardware. Normally, we are running on edge the algorithms using the processor. We are starting to use also the GPU, but normally we are using the processors of the hardware. To train the AI models, we are using different tools. We are using the cloud on Azure, and also right now we are starting to use Intel Getty. And finally, of course, we are using OpenVINO, as I was saying, to run and optimize the AI models. For us, probably this is the most interesting thing, and this is what changed our solution, because right now it's very fast how we are training our algorithms, and we are taking to run on edge the models. For us, is very easy and very fast, and this is why we are using this tool. And finally, we have an application where we are showing the results, and we can visualize everything that is happening in our system. And finally, the integration that we do with the rest of with the systems that you have in your company. So now let's see a quick video about how is working the solution. This is a picking process where we are taking all the different parts that we will use in our assembly process. This is something that we did. This is a video that we recorded at the beginning of starting working in our solution. And as you are seeing here, we have in the table all the different parts, and we are analyzing, and we are ensuring that we have all the different parts that we will use in the assembly process. So after detecting all of them, we are allowing the user operator in this case to start working on the assembly process. This is another video that we have. This is the application, how it looks like, how it's running in real time. In this video, you are seeing how we are recording everything that is happening and how the operator is working, putting together the different parts for the assembly process. In this case, I think that this is transmission, and we are analyzing everything that is happening in real time. We are telling to the operator if they are putting the part in the right way or something is wrong. So we are allowing to the operator to continue to the next step, or no, we are saying, please, you cannot continue because you are doing something wrong, or you are forgetting one part, and you have to stop and check what is happening. So imagine how many time and how many money we are saving to the company with just only with this solution. And finally, in this video, this is why it looks. Oops, sorry. let me play the video. So this is why the operator is seeing in real time the application in the factory. Here we are seeing everything that is happening. We are seeing in which step we are working. We are seeing the part that we have to take for the next step, and we are showing to the operator if they can continue or not. With all of this information, we are storing everything that is happening for traceability. We are storing everything that is happening in the database. So also we can analyze after that everything that is happening, and imagine to do a predictive maintenance, we can use all of this data, and we can get more information, more insights about the assembly process, and we can get more information about the process, and probably do like a predictive maintenance on other tasks that will help us in our company and in for our benefit. So finally, let's see how it's important, or how or what are the main benefits of this solution. This solution can increase the productivity, as you are seeing, because we are ensuring the quality of the product, and we are helping them in each step. We are giving the information in each step about what is happening. Of course, we can optimize the cost. We are saving a lot of money and a lot of time for all of our clients using this solution. Also, we are improving the quality because we are ensuring that everything is in the right place. We can guarantee the security because we can detect any foreign object to prevent, for example, accidents. This is something that also is very important. And something also that is very important is that we are improving automatically the algorithms as they are using, because we are using an automatically process that as much as they are using the solution, we are improving the AI model. So at the end, the performance of the models are increasing every time. So imagine in the future how powerful will be this solution. So that's everything from my side, Raymond. I think that I will let you do the demo.
I gotta switch to this side. I gotta rotate myself over.
Perfect.
All right. So this should be the live demo. 1 second. Again, it's live, so you can see me rolling around.
We are seeing
so what you're seeing right now, this is live demo, as you can see. We're doing real-time inferencing on the CPU and GPU at the same time. So what you're looking at on the right side, I have a very interesting machine. Maybe I'll do like a live session on my machine, my setup. Cannot be more live than this, guys. This is literally live. So this is the machine that actually has the Intel A770 mobile version. So it's actually very capable of running a lot of computer vision tasks in parallel. So right now, what you're looking on the screen is on the right side is, for example, the GPU load. So we can run multiple of this simultaneously. We still have a lot of, for example, headroom. But you can see this is doing object detection, segmentation, and then just for the fun, musical chair time. Boom. Works pretty well, 3D. And then works very well in motion. All right, back to this. So this is one example. This could be useful because remember, we have a lot of worker in the factory before they do assembly. This could be a very useful tool to, for example, like you have a shopping mall example before. We can also use this, for example, to ensure that we're getting the right information. And we're not done yet. So what you're seeing here is a demo. How do I run it? So this is what we call the OpenFino notebooks. So I just ran the last line, which is the demo line. But what you will actually doing most likely is you will end up learning what's OpenFino, how we do it. So we can almost treat this almost like a teaching material. So for our partner, for even your clients, they can actually learn a little bit of this and then be able to optimize the algorithm for their own use. So that's one. And then we also have the the human pose estimation. So this one I find it quite intriguing because this is one of the first things I tried back in the old days when I was working on computer vision. I tried to basically get my body pose because I was doing, remember, augmented reality. One thing I want to do is check my fingers, right? So this is no different than that, right? And then you can see today without 3D sensor, I can get my body pretty good. I can get my legs too. So it's like full body gesture. And then this is also very useful, I find, in many of the applications that I see in work actually mostly. So actually I do a demo so that I can always sit up so I don't like do this and do this. And then actually can use the human pose to help on my body. Now, to throw some big interesting name, because OpenPheno started as a computer vision library. Then over time, it actually supported NLP. So we also do birds, for example. And today we also support, for example, stable diffusion, like generative AI side. And some of the, for example, this is called a zero-shot image classification, is a part of the transformer side. And then we have been evolving as well. So when we met, we very focused on pure computer vision. Today we expand all the way to natural language processing, which I find very interesting. And in this case, I find this one in particularly useful because remember how we classify things? Like we always classify a cat and a dog, and then after you classify these two, to learn how the bird look like, you need to like put a lot of information about the bird.
Yeah.
Guess what? You don't need it. So zero shot, basically what it means is you can now generalize the model enough to make sense of things without having prior knowledge of this. So usually you have to have a data set of the bird, right? This time you don't. It's like, what? How does it work? Well, that's why we have this notebook for you to learn. We talk about the whole infrastructure behind it, the architecture, and how we use the transformer. More importantly, how you can get results. Let's say recognizing things without having ever seen it before. And that was like, you have to give some fine tuning steps here, but it works extremely well. And then that's something I'm very proud of. And lastly is generative AI. I think today I want to close it off with what's the future look like, right? Remember GPT and all that's coming up.
Yeah.
We also have a bit of GPT in the OpenPheno. So if you're interested in exploring it, feel free to try it. So I ran this, for example, this demo recently. This is basically the one that you can use for generating very beautiful images. So here we go. We have this one. It takes only 10 seconds to generate this one on the GPU. And that's really cool, right? We actually worked with the A770 here, the GPU from Intel on the generative AI side. And I have done one picture. I want to close it off with a picture of my wife. I just got married recently. You know, Mario.
Congratulations. Congratulations.
Yeah, so I have a photo of my wife and look how old. But we can use this photo as a guidance to create a water painting. Wow, look at that. Isn't that beautiful? Of course, my wife is more beautiful, but at least I can make water painting just like a professional with a very simple tool, like, well, not simple, but very easy to use tool with OpenPheno notebooks. And then that is where you can see it. Again, how do you find it? If you go on GitHub, OpenPheno notebooks, this is where you can download it. And there's all the instruction here. You can see all the notebooks behind it. We have all the examples. But more importantly is, if you try tonight, you make it work, text me. There's a chance you can put it on the LinkedIn. There's a chance I can pass around a hoodie as a, you know, free gift for everybody. I have one on the table. So if you can repeat the work today very easily, and then star me, and then tag me on LinkedIn. And how do I find me on LinkedIn? You type Raymond Lo 84. I gotta find a way to put it together. Maybe just like, maybe look for Raymond Lo Intel. Most likely you'll find me. That's me. Oh, that's my star. That's interesting. Oh, well, I was like, Engadget. So anyway, so that's how you can find me. Hopefully you find it all interesting. And I actually had a great time, you know, sharing this with you, Mario.
Yeah, well, it was a pleasure to stay with you today, Raymond. Thank you so much. The demo was really amazing, and how powerful is OpenVino and Intel hardware is really amazing. How you are improving every day. I love it. I love it. So
yeah. Well, thank
you so much for your participation. I think that you have If you are on LinkedIn, you have the text box if you want to send us any question, and if you are on Teams, I think that you have the questions and answer box. So feel free to send us any question that you have. I hope you like it and you enjoy it and you learn something about computer vision, manufacturing, and OpenVINO. So
Yep.
thank you so much for your time. Thank you, Raymond, and let's keep in touch.
Just in case, we need that legal disclaimer. And thank you.
Thank you so much. Bye-bye.
Thank you. Bye.